to the second webinar about debugging with UDE. In this webinar, we will have a look at the UDE scripting features. I will show you how you can use Python scripts and Python commands for automating your debugging task and your tests with the UDE. So this is the agenda for today's webinar. In the first few minutes, I'll give you a brief overview about the scripting interface that UDE provides, as well as some information about the technical background. Then I'll show you what you need for writing a script and how to write a simple script for testing an application with UDE. And I'd like to give you some hints about some specific tasks or specific use cases when you want to script. In the last few minutes, there should be a short tips and tricks session. In it, I want to show you how to add a custom user interface to your Python scripts and also how you can use it from within the UDE using our UDE Python console. So now let's get started with the introduction slides. In general, the purpose of UDE scripting support is to automate debugging and testing. That is the reason why we call this UDE automation. So all the features are handled or known or called UDE automation that I show you in the next few minutes. The typical way of work is that you control the debug tool by other software. The UDE automation feature is part of every UDE base license, and this is the first good news, it comes without any additional license fees. The heart of the UDE automation is the UDE Object Model. This is an open and flexible software API which provides access to all the debugger functions that you need. The UDE Object Model is based on the Component Object Model, COM, from Microsoft. And this is a deeply integrated and widely used technology and a quasi-standard and can be used with many scripting languages and programming languages as well. So you see that scripting is only a part of UDE or of the UDE automation or the UDE object model. The object model is also the base technology for coupling third-party tools to the debug tool. So for example, test tools can use the object model to directly test on real hardware using the debugger functions for target control and to get access to target variables. For example, to inject test vectors or to read test results. And here there comes the second good news. Because we are rely on the Microsoft COM, we benefit from some advantages. We do not need a proprietary scripting language, nor we are bound to a specific scripting language. That means that you can use any scripting language you like. You can work with your existing knowledge and your preferred tools, and you don't need to learn a new syntax, for example. Despite this, the examples I will show you later are all written in Python. I think that's a good idea because the most of you are familiar with Python, and Python is at the moment one of the popular scripting languages that are used. In order to make sure that we fully understand how it works, I'd like to introduce some of the principles and the architecture of the UDE object model. The UDE object model is composed out of a set of objects. These objects provide interfaces that give you access to almost all debugger functions. As you can see here in this picture, the objects are hierarchically accessible. We start from a top-level object, and each object, the top level and also the subsequent objects, provide properties and functions to obtain the next lower objects in that hierarchy. At the very top, there are two objects that are used as a starting point if you script. The first one is the so-called UDE launcher, which is used if you want to create a new debugger session. So in short, to start the UDE from scratch without a connecting to an existing one. And if you want to connect a existing UDE session or an opened UDE instance, then you use the UDE running instance manager, which provides functions to look for any existing UDE instances on your PC and connect them. From these top-level objects, you get the UDE application object, from where you can start to obtain all the other objects that you need. The UDE application is the root object of the debugger object model. And this and all the subsequent objects here in the box are the actual debugger objects that provide the debugger functions. One hint here, this picture does not show all the available objects. The objects model is much more larger than I want to show here on this slide. All the debugger objects provide a get method or provide get methods or object properties that you can use to obtain the next objects in the hierarchy. So with that small 4-line Python code, you can retrieve the debugger object to start the application on your target. So we get the access to an already running UDE by using the running instance manager in that case. That means we ask it for the first available UDE application object. Once we have access to the UDE application object, then we retrieve the debugger workspace object, which handles the debugger session. And finally, from that, we obtain the core debugger that allows us at the end to execute a go command, for example. Each object implements methods, as I said before, or functions, as well as it provides properties. This is an example of such an object. This is the example of the debugger object, which is one of the most important ones if you want to do some run control on your target. On the left side, you can see the provided functions here. For example, to read variables, to write variables, to start the application using the go command, and so on. On the left, on the right side, you see all the properties that we have. For example, to get the breakpoint object, which is one of the next objects in the object hierarchy. So with the breakpoints objects, you can, for example, add, remove breakpoints, and so on. By the way, this is a screenshot of our help system. So all the available objects of the UDE object model are well documented, and also you find links to more detailed information. This looks like it shown here in the screenshots. You see for each method and property, we have a definition block in a given in a more generic form here. You get also the description text, the explanation of the parameters, and finally a code example showing you how to use the specific function in one of the popular scripting languages of your choice. Here, for example, how this command is used or this property is used in the Python scripting language. So I think it's quite easy to understand, and it's a good starting point if you want to start scripting with UDE. So now it's time to see how it works in practice. What we want to do is to write a small test script for a simple application. The application under test realizes a simple clock. It simply counts up seconds, minutes, and hours. And we want to test the wraparound. So when a minute is up. So we expect that the seconds are reset to 0 and the minutes are incremented by 1. The application under test is running on an Infineon Aurix TC39, and for the test we are using the current version of UDE. Here you can see the hardware setup. I use an UAD2 Pro from our UAD family or access devices to connect via the Infineon specific DEP interface to the Infineon triboard, and the UAD2 Pro is connected to my PC using a USB connection. So for developing the script, I use the Anaconda Python distribution and a very nice browser tool that is named Jupyter Notebook that allows us interactive script development, and I think it's a very nice tool to start playing around with Python and with the UDE automation. So at first, I'd like to start UDE from a script. So the UDE itself is not started. I have prepared such a script already to save time here in this webinar. This is the Jupyter Notebook, and you see some cells in it where I can write some commands, Python commands, and from that I can create a complete script, and I can save, of course, this script and use it later in a Python shell or from the command line. But for now, I'd like to use it to execute this script step by step. And the first thing what we need to, if you want to use the UDE Object Model, is to import a library which handles all the communication to the Windows or the Microsoft COM interface. This is the win32com.client library. I execute this line here, so now the required library should be available, and that library I use to ask the Windows system for a service which is called the UDE launcher. You remember the UDE launcher can be used to create a new UDE debugger session or to open a UDE. So we need that one, and we ask the COM library here for the UDE launcher. And in order to make sure that everything is working, I print out some version information. This is successfully done, so you have now access to the launcher object. Before we start or before we open the UDE, we need some files or file specifications, a working directory. We need a workspace file which saves all the debugger session settings, like the opened windows, like the application that should be loaded to the target, etc. And we also need a so-called target configuration file, which contains all the settings for connecting a hardware, in our case, the Infineon triboards using our UAD2 Pro. The config file is already prepared and is located on the disk, and the workspace file will be created from scratch. So we execute these 3 lines, and now it's time to start UDE. This is can be done using the start and create workspace command of the UDE launcher. So the UDE is now opened, and using the target configuration, we have also a successfully collected target with 6 cores here. And also we get a printout of the UDE version that I use. And then I like to open or get connected to the workspace, which is the root object of our debugger session. From that workspace, we want to get the debugger for the core 0. Before I do that, it is a good idea to check if we have a successful connection. In that case, we see it here in the message window, but if you write your own script and do execute it overnight, for example, then it's a good idea to use this statement here or these 2 lines to check if we have a successful connection. It is, and then we obtain from the workspace object the core debugger for the core 0. This is the most important line. The rest of this cell here of this little code snippet is only to provide some information or to print out some information about the connected core. You see this is core 0, a tri-core and a TC1.6 tri-core architecture. So, and now we want to load a hex file or an ELF file into the target. We have one on under the working directory. It is called timedemo.elf, and I use that to program. I can load it into the RAM. In this example, this is a flash example, so it is automatically flashed into the internal flash memory of the RX device. And then it's time to start the application. We make it go, so we see all the cores are running. We see not very much. I have some LEDs blinking here on my board, but you can't see it. So I decided to ask for some, or the seconds variable, which is part of this application here, and read it several times. And you see it's counting up, so it seems the application is working. So that is the first example that I'd like to show you with opening the UDE from with the UDE launcher. And then we can clean up everything and also close the UDE. Okay, the second example I'd like to show is the test that I have promised. In that case, I want to get access to a running UDE, so I have to open the running UDE with a predefined workspace. The same application, I have opened already some more windows, and now it's time to connect. And for the connecting, I don't access the UDE launcher. Instead, I ask the Windows system for the UDE running instance manager. It looks quite the same. We get also a printout of the UDE version that we are using. Then we need to get access to the workspace, as I have shown already. Then we want to get access to the debugger, the core debugger for Core 0. It's quite the same as before. We start the application. You see some variables are incrementing here, and also the seconds is counting up. And then we want to test the update function for the seconds. So it is always a good idea to set a breakpoint at the beginning of this function. For that, we need a breakpoint object for the Core 0. So we have already the debugger object available for the Core 0, so we can ask the debugger object for the breakpoints. So we now have the breakpoints object, and then we can use the breakpoints object to add a breakpoint at the update seconds functions. And with add and result, you get you add the breakpoint and also get any error if this fails. So you see we have added the breakpoint and hit the breakpoint as well. Here we have also a check if the breakpoint or the breakpoint was already hit. It's always a good idea to use these checks before you continue your script. But in this case, we see it is successful. It was successfully this command, and we can execute it as well. And then we want to insert or inject our test case. I said before we want to check the wraparound if the if 1 minute is up. So we set the seconds variable to 59, and we want to make sure that we have no hour wraparound. So we set the minutes somewhere between 1 hour, so for example to 10. So I execute this two-line statement here. The seconds are now 59, the minutes are 10. I save the minutes before for the later check, and I print the current application state, so everything looks fine. Then I remove the breakpoint and set a breakpoint at the end of this function. So remove and get result is the function for removing, and as said before, add and get result is the function for entering inserting a breakpoint. In this case, I use this expression here which sets the breakpoint in the update seconds functions and using a line offset of 8, so that we are on the end of set the breakpoint at the end of this function. So the breakpoint is set, then we can make it go, check for that we halt on the new breakpoint, and then we read the seconds and minutes variable again. And these 5 lines check if the seconds are reset to 0 and the minutes are incremented by 1, and then we get the result and the test has passed. Very, very nice. And then we can remove all the breakpoints or the breakpoint that we have set, make it go, and clean up everything. Okay, based on that, I'd like to show you some or give you some tips or some ideas how to deal with symbols here in this application, or you want to deal with variables, enums, and also local variables. This is also a script which accesses the already running UDE. The first lines are the same as before, so we get access to the UDE, the core debugger of Core 0, use the workspace object, etc. And here I'd like to show you some more functions that you can use for dealing with symbols. For example, you can get access to the symbols object using the debugger, and the symbols object provides useful informations or useful functions to get information about the symbols of your application. For example, the count of the enum values for a enum called quarter. So you can also iterate through all the enums, get the name and the value. You can also access or use the symbols object to get all the functions in your application, and also print out all the functions of your application with the addresses and also the names. And you can also get all the variables, the global variables with fixed addresses. So that means these are located in the memory. We can also iterate using a for loop for through these variables. You can also print the variables with its scope. It's also possible. And you can also print information about the local variables that have no address in the memory, but are on the stack or on the heap. And with that, you need to break the application. I use the already known breakpoints object to break here in this delay function. For example, we have here two local variables. You can see it in the locals window here. And if you want to read some of these local variables, then you have add or prefix the variable name by this @ sign. Then I read out this variable, and I can also write this variable here, and so on. Okay, with that, I'd like to end the first part of this webinar and the introduction into the UDE object model and how to use it. Finally, I clean up, start the application again, and yeah, switch to the slides again. So I think you have an idea how to use the UDE object model in Python. It is quite simple. You can check the documentation that is provided with the UDE, and we have also a application note which explains how to use it, how to use the object model with Python and also with other scripting languages. If you are interested in, then you can request it by contact our support team, or if you want to have it, then post me a note here in the Q&A section of the webinar tool. Okay, now I'd like to come to the second part of this webinar with the promised tips and tricks session. Here I want to show you today how to create a little user interface so that you can control your scripts interactively too. this is an idea that we got from a customer. So, and I'd like to share it with you. And yeah, in my example, I use the a simple GUI Python library. Here is the link to this library, to all the information about it, and also to the documentation. You can use your Python environment or distribution to install it. It's quite easy. This line here, the normal Python installation method can be used to get this little library. Okay, so I'd like to show it. I open the UDE again, and I have already prepared a script that is using this library. The first lines you already know. It's very, you will find it familiar when you look at the scripts before. We get the UDE again, and also the workspace, and also the core debugger for Crossio. And I forgot to mention that you have to import the this simple GUI library that you can use it in the script. And this we use it as a SG here in this case. And in order to create a little window with some buttons there, we need to specify the layout of this window. It is also quite simple. There is a struct which we create, which provides us some functions here or some properties to create text in the window, to create buttons in the window, and how they are arranged in that window. So I create this struct here, and then I'd like to open that window. This is not that these are all things that are not, it has not to do with UDE itself. It is pure Python here in this case. So we open the window or create the window, and you see this window is popped up, provides a status line which tells us which time we have, and provides 4 buttons. But it tells the wrong time. You see here the timer values, seconds, minutes, and hours are counting up, and we can't do anything with the buttons here, and it's not reacting here the window itself. What we need is to define a event loop, which looks a bit complicated, but it isn't that complicated. For all the time, using a while true loop, we want to read inputs on the buttons here, and also inputs coming from the UDE. We use the object model of UDE to read the variables hours, minutes, and seconds to print out it on the top. And we wait for some commands and use these commands to control the debugger, make it go, make it break, or reset the clock here. These are the lines here that we need for that. So I execute this, and then you see, okay, now the while loop is executing, and we're counting up, or you see the timer is counting up, and we can stop the application, we can start the application again, we can reset the application. That means we do a break and we write hours, minutes, and seconds with the value 0, and we can start the application again. And then we can also exit the application and clean up everything. And that's all that I want to show you here. I think with that little GUI, some of your scripting tasks will be more user-friendly, and I think it's a good idea to show you that in this format here. The last thing I'd like to show you today is how you can also use scripts internally from inside the UDE. Until now, we use a external tool or a external scripting language, but sometimes you want to automate your task from inside UDE, like it is like you are already used to from macros. For this purpose, UDE provides a UDE Python console. This Python console is a window in UDE that understands UDE commands and also Python. You can write your own commands in the console and execute them instantly, but you can also execute complete scripts that you have written, for example, in a script editor. And this is like a macro then. And that I want to do. I'd like to port the simple GUI example that I have shown you a minute before to an internal script and executed it from inside the UDE. In order to get the simple GUI working, we need some installation steps before. It looks a bit complicated here, but it is quite simple and will take 1 or 2 minutes. You have to load a zip file and unzip 2 files and put it in the installation folder, in a subfolder of the UDE installation folder, and then you have to open the Python console and import this library. And once you have imported it, then you can use it in every UDE sessions afterwards. Okay, how it looks like. Let's jump back to the UDE and open the Python console, which is in the view menu, other windows, Python scripting. I took it out, so make it a bit larger. And this console you can use to control the UDE without clicking a mouse. You can insert commands. You do not need to use the a launcher or a running instance manager. The UDE application object is already present, and also the workspace object, which is named UDE workspace. From that you can get the core debugger. You see you have a command completion here, get workspace debugger, and then we define a core 0 variable, core debugger 0, and then you can, for example, do a break, core 0, break, or you can make it go. Okay, that's quite easy, and for some of you who don't like to click too much, it is a good alternative for interactively control the UDE. But you can also load some scripts, and I have already prepared such a script, which is quite the same as before. You see here on the header, we use the simple GUI as before. We do import it, and then we obtain the debugger object from the UDE workspace. And the UDE workspace is already a object which is automatically available if you are using the Python console. And then it's quite the same as before. We define the layout of our window, we open the window, and we implement the event loop for that. It is the same code as before. And when we start it, right-click Run Script. This is the script here. I load it, and it is automatically executed. Then we have our nice little GUI as well. We can stop the application, we can start the application, we can reset the application. And yeah, maybe it is helpful for you if you want to make your automated task much more user-friendly. Okay, and that's all for today. We have 40 minutes are passed. At the end, I'd like to say thank you for your attention. And if you have any questions, then please use the webinar panel for that, or drop us an email. In the next few days, I will check that. And if you have any questions, I will answer these questions, send you an email. And I'd like also to make an announcement for the last webinar in this 3 webinar series, which is held on April the 7th at the same time. And in that webinar, I will be go to more into the profiling task with UDE. We want to find bottlenecks using trace, and I'd like to show you how or which tools in UDE can be used to hunting for bottlenecks. Thank you very much.